Hello. Today we're going to be moving on to Unit 11, which is trigonometry, and it is my personal favorite unit, so I'm sad that I can't teach you guys in person. What we're going to be doing this week is going to look really familiar. We're starting out with right triangle trigonometry, so you already learned a lot of these concepts back in geometry, so the first part should seem really familiar. The first review idea is recall that you've already learned about three trig ratios in geometry. So in geometry, you had this right triangle unit, and the three ratios that you learned relate specifically to right triangles and their sides. So the first one is sine. Sine is opposite over hypotenuse. And on your calculator, you can find sine. It looks like sin. It's SIN. It's abbreviated down below here, but it's pronounced sine. And then we have cosine, which is adjacent over hypotenuse. And then the last one is tangent, which is opposite over adjacent. And a tangent is abbreviated. Oh, I spelled adjacent wrong. TAN is the abbreviation. I cannot spell today. Okay. The shortcut to remembering this, depending on who your geometry teacher was, is SOHCAHTOA. So SO is sine, stands for opposite over hypotenuse. Ka is cosine, adjacent over hypotenuse. And then TOA, tangent, is opposite over adjacent. So that's one way that you can try to remember these. Remember that trig ratios are used to find missing sides and angles of right triangles. Another useful tool that we'll be using in this unit is the Pythagorean theorem. Remember that is our a squared plus b squared equals c squared. And we use Pythagorean theorem to find missing sides of right triangles. Now this is new. There's also three other ratios, which are the reciprocals of the original three. So the three new trig ratios are cosecant, secant, and cotangent. Cosecant is actually the reciprocal of sine, and secant is the reciprocal of cosine. It's kind of backwards from what you would expect, but cosecant is partners with sine, which means if sine is opposite over hypotenuse, the reciprocal of that becomes hypotenuse over opposite. Secant is the reciprocal of cosine, so this one becomes hypotenuse over adjacent. And fortunately, the reciprocal of tangent is cotangent, so now it just becomes adjacent over opposite. Okay, so sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. A little bit odd, but you'll get used to it. I'm going to skip this next example because it just goes over the ratios, which we just talked about, and we're going to do something very similar in this next problem. Just remember that whenever we are finding all these different ratios, look for the theta angle. Remember that theta is just a variable like x, but we use it to represent angles. So across from our angle is the opposite side. Directly next to it is the adjacent side, because adjacent means next to, and then the hypotenuse is always across from the right angle. It's always the biggest side. So here we have some actual numbers, so we can apply this. So sine of theta, here's theta in this corner. Sine is opposite over hypotenuse. So let's go ahead and identify our different sides. So this is opposite. This is the adjacent. And 13 is the hypotenuse. So sine is opposite over adjacent, or opposite over hypotenuse. So we get 12 over 13. Cosine is adjacent over hypotenuse. So the adjacent side is 5 over 13. And then tangent is opposite over adjacent. So the opposite side is 12, adjacent is 5. Now that we know these, if you know the partners, you can pretty much just flip them, and it's pretty nice. So sine and cosecant go together, so those are reciprocals, so we just flip it, and now hypotenuse over opposite for this one. And then cosine and secant are partners, so it becomes 13 over 5, and then we get 5 over 12 for the last example. Like I said, if you know the sine, cosine, and tangent, it becomes pretty easy to find cosecant, secant, and cotangent. All right, next part. And I'm going to break this up into 2 separate videos. So this will be the last example for the first video. We want to evaluate the 6 trig functions of the angle theta shown in the right triangle. Okay, so notice we are missing a little bit of information. We have our angle, we have the opposite side, we have the adjacent side, but we are missing our hypotenuse. But since this is a right triangle and we have 2 sides, the way that we find missing sides is the Pythagorean theorem, like I mentioned earlier. So we want to use that a squared plus b squared equals c squared for this problem. A squared is going to be 5 squared, b squared is going to be 10 squared, and a and b can interchange, it doesn't matter. But c is what we're missing, so c squared. So 5 squared gives us 25. 10 squared is going to give us 100. Don't know what c squared is yet. Let's go ahead and add these together. 125 equals c squared. Then we would take the square root of 125. Now this would be a decimal answer, but since we've already practiced with radicals, we can reduce this into simplified radical form. So if we were to break up 125, we would get 25 times 5, break up 25, and you would get 5 times 5, so we have a pair of 5s, which means 5 goes on the outside, and then we have a lone 5 right here that's going to stay inside. So 5 square root of 5 is the simplified radical form. So the hypotenuse is 5 square root of 5. All right, now that we have our 3 sides, let's go ahead and write these out. So the first thing is sine, opposite over hypotenuse. So I'm just on the left here, I'll write, just as a quick little reminder. So the opposite side is 10, and the hypotenuse is 5 square root of 5. We can reduce this, and the problem with this is the fact that we have a radical on the bottom. But since we have 10 and 5 on the bottom, or 10 on the top, 5 on the bottom, we can reduce that to 2. 5 on the bottom becomes 1, and we're just left with the square root of 5. But we still have that radical 5 on the bottom. So if you remember, to rationalize the denominator, we need to multiply by what's on the bottom. So the top becomes 2 square root of 5, and then square root of 5 times square root of 5 ultimately becomes 5, because you get the square root of 25, which we know to be just 5. So the final answer is going to be 2 square root of 5 over 5, like that. Okay, so that's for the sine. Cosine is adjacent over hypotenuse. So the adjacent, now we have 5 over 5 square root of 5. And 5 square root of 5, this would reduce to 1 over the square root of 5. But again, can't have the radical on the bottom. So we would have 1 over the square root of 5. We would multiply that by the square root of 5. Square root of 5 goes to the top, and we got 5 on the bottom. So this is our final answer for the cosine. I wish I would have left a little more room. Tangent, opposite over adjacent. So this is opposite over adjacent. The opposite is 10, the adjacent is 5. So we get 10 over 5, which we know equals, I'm struggling to write 5s here, 2 is the final answer here. Don't have any radicals to worry about on this one. Now for cosecant, we know that that's the reciprocal of sine. So what I'm going to do here is, rather than take the reciprocal of 2 square root of 5 over 5, I'm going to take the reciprocal of this one right here, the 2 over the square root of 5. Because what happens is, now that radical flips to the top, and 2 goes to the bottom. It would be the same if we took the reciprocal of our final answer for sine, but then you would have to do just a little bit more work. It's easier to look at the one that I starred, this one right here, and then take the reciprocal. So same thing for cosine. Let's look at that inside the 1 over the square root of 5. The reciprocal of that would be square root of 5 over 1, which just equals the square root of 5. And finally, cotangent. The reciprocal of 2 would be 1 over 2. So it's 1/2 for the final answer on cotangent. These can be a little tricky with the radicals. There's more than one way to get the final answer. Just make sure that you don't have any radicals on the bottom of your fractions when you're doing these kind of problems. Okay, you can get the rest of the information for the next half of the notes in the following video.